specialist and excited to teach you a little bit about GIS. We cut down part of our intro workshop. So if you're interested in learning more, there's a lot more information that goes on in our introductory workshop called GIS Level 1. But we got the main highlights here for you guys. Okay, you must be used to Zoom by now, but again, we welcome, you can interrupt me anytime to ask a question by unmuting, or if you prefer in the chat. I had to drop down to one screen because things were a little funky, so I'm sure my colleagues can let me know if there's any chat questions. It'd be great. Okay, so normally when we're back on campus, we have a beautiful renovated, it's pretty new, giant lab in the first floor of Roach Library. Roach Library is actually two buildings smushed together, so you actually have to go down the back stairwell to get to that first floor of that building. But once you do, we have 16 Alienware computers, incredibly powerful. We not only have GIS, spatial data visualization software, we have 3D modeling, we have statistical software, we have text mining and Vivo, we have remote sensing, image analysis, we have VR software. We're basically the spot. We're also housed next to data management. So we're actually the spot for any kind of interdisciplinary needs in your research outside of your direct liaison support with your liaison librarian for your department. So we can help with the workflow, with data visualization, data management. Great spot. We'd love for you guys to come. You can actually access our computers remotely during the pandemic. We have more information there. If you ever want to email us a question outside of help hours, we have our help address. And we also have a LibGuide packed full of how to download the software, data links, and just more information in general. So what is GIS? Well, GIS stands for Geographic Information System. It's simply just a system for working with spatial data. And what do you really need to know about it? It doesn't come with its own data. So like many software, if like statistical software, you just kind of open it, you input data into it, and then you export the data for some other use. Same with GIS, so don't expect the data to come inside of it. And we'll give you some tips and tools on finding data a little later. So again, still, what does that mean, a system working with spatial data? Well, you might recognize this. This is a Google map, and a Google map is actually a GIS, a type of GIS. It's a geo browser. It's one of the weaker we'll learn about in terms of the analyses that you can use. Even though Google Maps has incredible traffic and routing and querying capabilities and use beautiful satellite imagery in the background, you can actually do quite a lot with different levels of GIS software. So we have little exercises throughout, and in this one, just keeping in mind that GIS basically works with a whole bunch of different data layers, literally layered on top of each other. Can anyone guess, and feel free to throw out answers in the chat or just aloud, what data layers do you see in this kind of standard Google map? And you're probably right, it's just, yeah, here we go. Streets, perfect. I see some width. We'll learn later that they're using polygons because the streets have width. Parks, perfect. Neighborhood, points of interest, wonderful. Rivers, water, businesses, exactly. So GIS is made up of layers. All the parks would be, or open spaces as they usually call them, is one layer of water. Exactly. So we'll learn more about what's a GeoBrowser compared to other GISs soon. Okay, so you have a small taste of what a GIS means. What are some other applications? Well, the first time Google Maps came aboard, everyone was looking for their house. because they wanted to go see the best satellite imagery around. You can definitely use a GIS for that. I actually teach the satellite remote sensing class. There's so many satellite products that you can analyze in all sorts of ways, and then you usually bring them into GIS as part of a whole workflow pipeline. GIS can also do some 3D modeling. A lot of the architecture students actually export the data into CAD or Rhino, which allows you to extrude those building polygons based off of a height field. And so that'll just shoot them up and then you can color code them. But this is a little idea of like the beautiful visualizations that you can make. And they're not hard to make. This is kind of the more standard view of what GIS does. You make a beautiful map. I like to kind of also say that it's not just the science, but it's also artistic in that this is an Irish heritage map. And so of course they're using like a very Kelly green color, and they're using an ascending color scale with probably equal breaks and different shades. So there's a lot of thought that goes into a map and some science and like how you divide up the data and colors and things that you use, but they all come together for very nice visuals of spatial data. Again, GIS just for visualizing spatial data. But you not only want to visualize data, but you can actually manipulate the data sets that you put into a GIS. So you could do something very simple like edit the geometry of two different layers. So if you look at the far left, that's actually one layer that's all the water, the hydrology of Massachusetts, or beyond probably New England, because it extends beyond it. And then you have a geometry of just the border of Massachusetts. And by using a clip tool, you can cut one layer by another. And you could imagine that that's useful for making a very clean map, or maybe you only wanted the water information for one area. So that's a very simple, you edit the geometry by using a clip. Other type of analyses, you could actually create brand new data. So in the bottom right, if you had a little island and you wanted to say, how far can this isn't a good example, it's coming to my head, like rocket get over a certain distance, you could do what's called a multi-ring buffer tool. And that would create new polygon data around your input. So not only can you edit the geometry of layers, you can create new data from it. You also can analyze the values stored within the data. And that's probably the most powerful and interesting, even so much so that you can run spatial statistics to actually say that there's hot spots of the values over here or cold spots, and they're statistically significantly different. So it's pretty neat what's possible, but I'm biased because I love my job in this software. That all said, there's you do want to know about data types. We're going to give you a really brief overview. The different ways to represent real world data in this digital computer software is the way that people come up is you can use coordinates, X and Y's, and these are usually called vectors. And these can be points or lines, connected points, or they can be polygons. A lot of people are familiar with this. There's also raster. These are images. These are what uses the rows and columns, and we use pixels or cells. Why do we care? And what kind of data more so would people put into the vector format versus the raster? Well, it all comes down to that the vector, again, are using these coordinates, and those are really a lot better for man-made data because a school is in one exact point, or a building is usually like a nice square or something. So those are better described with vectors and coordinates. Meanwhile, raster data is much better for environmental data, which changes kind of smoothly and continuously over the surface. And each pixel has its own number or value that can like slowly change. You can think of, for good examples, elevation doesn't, that kind of has a smooth transition, temperature, precipitation. A lot more environmental variables are stored as rasters. But in a GIS, you can actually convert from one to the other, vector to raster, to use different tools in the system. Feel free to throw out any questions. I see in the chat. Okay, so what are some examples of raster? People are like, that sounds something like I've not experienced before. Actually, it's just aerial satellite photographs. It could be a digital elevation model. It could be just a picture of an old map, which often a lot of humanities, you will find that they'll take pictures of old maps and then they'll upload that image into the software. And then you do a process of kind of sticking little pins to say, oh, this little spot on the map, I know where it is in the digital map, and you pin them together and you slowly pin down the image into the digital space. And then you can trace the features off of the old map and you digitize them. So that's the process of digitizing features from that. Okay, so there are, how you might still be thinking rasters are still a little foreign to me, but how might I recognize them? Well, they usually have these extensions. And let's see about these folks. Yeah, usually JPEGs or images or anything that you took the picture with of the map. If you go to Harvard with their great collection, with our relationship with them, they have an incredible, Juan Young will help you in the map collection there, and they take wonderful pictures. Okay, so here's one more exercise. Here we have points, example of points, lines, and polygons from real Cambridge GIS. Has a whole repository of Cambridge data. And this is the Boston GIS. That's my only clue. Does anyone know what in the combined picture, what are these data sets, especially how they've been symbolized, how they've been color coded? Can anyone guess what that data is? Yay, the T, rail, perfect, exactly. So data is digitized real world data. And because the T-stops are in set points, they are better reflected with points. So different coordinates for that. Then of course the connection between the different lines are best symbolized by a line. And then the different, I think these are tracks. Sorry, I remember I still don't miss it, but yeah, that is. And then you start to see now how you can actually symbolize is an often word used in GIS. So how you color code, how you display the data based off of their values. So how does the software understand what the values are linked to this data? This is about the most technical that we'll get, but I think it helps you understand how it works. So all of these GIS data have a front end. You see the points, the lines, the polygons, the raster. And here's a zoom in at that area. Rasters have kind of smooth connections. Vectors. But there's a table. There's information associated with that geometry, where rows are each unique feature, each unique geometry. This is a polygon data set, so each row in this polygon is a different polygon as part of the whole set. And in this case, we can just kind of roughly tell that it's New England. Also, I named the layer that. So each row is a different state in this case. And then columns are all the practically infinite variables you could associate with a state. You could say, what's the total population? What's the number of schools? What's everyone's favorite color, the most common favorite color? Like you could really associate any variable possible with this. So let's say we have one column that's all the names. Are the tiny islands separate? So those could be multi-patch polygons. I'm not quite as familiar. They could be, if you wanted to have little different islands, those could be different rows if this was like a different shape file. But I think for this one, they put all of those islands, all those little mini polygons as part of the same row. And then in the back end, it just knows that all those separate little polygons are all part of one group. So now we have this, we have the geometry, that's great, but what if we wanted to symbolize? If you symbolized on the first column, which is categorical data, you could give each state a different color, as in this case. But if you are symbolizing on a column that has a numerical data, you might use one color, like we saw with the Irish map, kind of an ascending color pattern. So I know we're touching upon this kind of quick, but I just wanted you to see the connection between the front end, the map, and then how you are symbolizing by using the data table. And AJ is going to teach you later how to actually formulate a table from scratch to work best in a GIS so that you can start symbolizing your data right away. So that all said, to recognize vector file formats, a shape file will have a whole bunch of files in it, but the whole thing is technically a shape file. And then what will be most applicable most often to this group is that you're often going to be using tabular data and making it spatial. And how you do that is you just need a table that has a latitude and longitude so that the software knows how to plot the data. Or you could have a full address field where you have the address, the street, the city, the zip, the thing. And I know that's hard to get sometimes, but if the software has either an address that it can match with coordinates through a process of geocoding, or it has a latitude and longitude, it can plot all the points that you give it. You can also, as we discussed, do digitization with an old map also. Oh, sorry. Yes, sorry, just saw your thing. I hope I didn't. Hopefully you can read this table with the audio issues. But there's a lot of ways to go from tabular to spatial data. You just need that lat long or address. Or you can create your own data with the GPS that you can borrow from the library. So some common tabular file formats, CSV, XLX, a .dbf is actually part of a shapefile. You can pull out just the table extensions, the .dbf, and use it in Excel. Okay, so we're going to do a quick demo for how you would create your own tabular data to best work in GIS. So I'll hand it off to AJ. Oh, I think you're muted.
Wonderful unmute issues. Okay. I'm hoping that everyone can hear me okay now, and you can see the template that we have put in the Dropbox. You can also see that this is an example. It's by no means everyone's data set is different, but we thought about since humanists tend to create their own data sets, we wanted to give folks a sense of how to organize and how to document one's data sets. As an example, some of the things that we think data sets that will be fed into a GIS, whether it's Carto or something else, should have. So we created this dummy set that has a number of columns that would obviously vary depending on the kind of data that you're using, but the ones that would be required for any data set to be mapped onto any kind of GIS would be the latitude and the longitude, or the geocoding has to be in place for that to work. So the latitude and the longitude are separated in different columns. Carto, for example, will automatically join them, but as a first starting point, it's helpful if we separate those data into different columns. And then the name of the place, right? It could be any place, and it might have a geo ID. We'll sort of define what that is. It's a label source for the geometry that can come from a source like GeoNames, which is a giant repository of place names all around the world. Going back to this, it could also have a country code, which is almost always helpful to have, even with historical data, because country codes, depending on the layer of accuracy we have about the place, it could be a container if, for example, there's some information that's uncertain about the location of the place, but we know that it's close to a country. It could, if we still want that place to be mapped, it would be helpful to have a more, not 100% accurate, but a broader sort of set of geographic data to make up for that lack of certainty in certain terms. Sometimes it's also helpful to have the source of that place, especially in historical data sets, historical geo data sets. And the source can have its own ID that can refer to a different table. This table could refer to a different table, in other words. Again, it could have a start year, obviously for historical data. We may not be certain about that, and an end year. It could also have an alternative name. Geographic data also change, and historical data obviously do, and there might be multiple names in various languages. And in order to make up for that, we could have a column that is entitled alternative name, first one, second name, however many is needed. Geographical places can have different types. It can be towns, mines, and all kinds of things. I'm a medievalist, so I have to have the castle in there. And it could be relevant, for example, historical climate data. It's always relevant to have elevation information in there that could be also incorporated in the data set. And matches and notes section that can include any kind of free text data that's helpful for the person looking at this data set to understand. The key points that I want to make that it will be super helpful for you all to walk away with is it's obviously for humanities folks, especially to make a geodata set, is a very cumbersome process. And Madeline and I thought it would be helpful to give some guidance. Obviously, this is not by no means incorporates all the things that need to happen. But the main thing that we're trying to communicate here is to think broadly, not just about the data that you're trying to encode, but try to encode some proxy data alongside it, just like the country code that I was referring to. And also to document the decisions that you're making as you're making your data set. So here is, we have kind of defined for this specific data set, we've just defined some rules, especially if different students are entering data into the data set. It might be helpful for them to know what rules are governing this data set. So first row must be one row of column names. You can kind of specify all of the rules associated with this data set. And it was also helpful because not everyone will recognize everything from the get-go and what all of those column names mean. It's also helpful to have a code book associated with this place. This example comes from a historical data set that's called World Historical Gazetteer. And I want to show you quickly how this table itself, even though it's super simple, can be linked to other tables. Especially I want to draw your attention to this type 1, type 2 columns, column M and N. And there's a whole different data sets that is associated with this that kind of defines and gives the source and all the other relevant information about, about these terms. And they come from what is called Getty's Art and Architecture Thesaurus, and they've identified all of those ID numbers. So a place can be an inhabited place. What do we mean by an inhabited place? So it's a simple, the entries can be simple, but it can be related to multiple data sets that each ideally should have their own code book and referencing to facilitate both the folks understanding what is in this data set if they were to use it, and for hopefully students who and anyone who is contributing to who's making the data set. I'll stop there. Are there any questions, or Madeline, have I missed anything significant?
I think you did a great job, especially connecting tables is really great in a JS, and that's a great reference. And just basically those rules there are just what makes it work in JS. So the only thing I would bolster is what you said about, because the column names can only be 9 characters to work, often that's not enough to let people know what that data means. You always want a code book of metadata and like a README file that helps people understand what, and you, when you return to your project or give it to someone else in a year, what those meant.
Well, thank you, Madeline. What I just dropped in the chat is actually the source of those tables, if you want to kind of take a look at where that comes from. And I will put another link in the chat, which kind of is a repository for historical data sets. There are multiple data sets in there that can be helpful to take a look at, including the one that we have just talked about. So those are there. Madeline, are you taking over, or am I continuing your takeover? All right.
I think it's on you for the Carto demo.
Oh, we're starting the Carto demo. Wonderful.
Oh no, I'm sorry. You are right.
I thought we had a few more slides to go.
You're totally right. You guys see the present preview? Okay. So we demoed the tabular data. Okay, so there are a ton of data formats.
And Madeline, we're seeing your notes as well. Yeah.
You can't see it now. So there's tons of data formats that can go in and out of these visualization softwares. The main things that you'll recognize are shapefile, or geodatabase is really the proprietary format for just the Esri ARC family. But really shapefiles is what you'll want, or the tabular data if it has, again, the lat long or an address field. But people make fancier, more beautiful maps using Illustrator. You can get data or export data to keyhole markup language, which Google uses. CAD gets you into the engineering. People are architects with Rhino. TIFFs is kind of a standard raster, and then a JPEG is just a picture, which also has cells and things. So that's massive. This slide looks terrible to read it all. It's the most helpful one we have, because the truth is, because the software doesn't come with data, most of your first stop is finding the data that you want to get. What it basically comes down to is that you really want to think about who might have the data that you need and what repository they might have stored it in. So unfortunately, I only know more environmental examples, but if you want rainfall data, you're going to go to NOAA. If you want land data, you're probably going to go to USGS. If you want census demographic data, you're probably going to look for the census. If you want very specific detailed elevation data, you're probably going to go to the most nearest big university to the location that you're interested in. Because most often they have a library, most often they have a GS person, and most often they might have some data sets. And never be afraid to email authors of papers asking for where their data came from, or if they'll share it, or also different people, because it costs a lot of money and time to host data. So a lot of people might have data that they're willing to share also. And then AJ collected these amazing list of links that will be very helpful for different data sets as well. Another place, MIT, like many libraries, have their own repositories of data sets that we purchase, mainly India and China data. We also got a big European historical data that people would be interested in. Go back to 1400. And so this is our repository, and it also shows you data sets that are, the licensing is unrestricted, so other schools, it's actually a collection of Stanford, Princeton, Harvard, Columbia, and so any data sets that they end up collecting that are able to be shared, you can actually download from this site as well. And then the restricted ones just means that they purchase that data set, but it gives all the metadata that we're teaching you how to write with the code book. It has all the metadata, so we would know where to go to purchase the data if MIT would also like to get a copy. I saw. And then our LibGuide. In our LibGuide, you're going to find information about the computers, what software is installed on each. What's probably the most helpful is under the Find data. We have all of these data links, just similar to the ones you saw earlier, by themes. So it could be geology, business, census, elevation, energy, all sorts of themes, and also by location. We also have for LearnGIS, we have our tutorials that you can take anytime, getting and downloading the software directly. That, our last slide, or second one, we talked a little bit about the different types of GIS. Google is a geo browser, and you can display data and has beautiful visuals, but you can't really do many, if any, of the analyses that we briefly touched upon before with editing the geometry, visualizing the data within it in the table, or creating new data as in the buffer from it. The strongest, but the very steepest learning curve, so it's not always worth your time, is our desktop software. And these are what our workshops mainly teach, GIS level 1 and 2. So if you think you'll be doing a ton of visualization, it's worth it. And we have really great workshops for that. But for a lot of people who just want to get up and running quickly and don't want to have to overcome this big learning curve for figuring out this new system, I love it once you're used to it, but it can take some time. Web-based are getting better and better. We're going to be teaching you Carto today, and it basically lets you quickly upload data, and they often standardize the symbology really quick, so you don't have to figure out all of the steps that it takes to symbolize data. It just makes a lot of the steps a lot easier. You do have less control a bit, and you don't have all of the analyses possible, but it's a really wonderful mid-ground for getting started with it. And then a little bit more in detail, we have even more comparisons between the two. Web mapping, also what you're going to be learning today, has the extra benefit of it's the best one that if you're in a meeting with multiple people and you want to dynamically change different variables or turn on and off different layers, so that people can see how the data could change with different decisions. Web mapping's even the better choice. The only problem is that they can't hold as much data at once, so you often can't use rasters all that often on them, where you can only use one, and you're often limited in the number of features and analyses, but the analyses keep getting more and more advanced. Each time we teach this workshop, there's some awesome new analysis that Carto has added. And here's a ton of options. There is an GIS Online one, there's Carto. Story maps are almost a great way to do a presentation where you embed interactive maps in, and Social Explorer is really good as well. That, we're coming to the end of the intro to GIS, and we're going to get you some hands-on time with Carto.
Thank you, Madeline. Let me start sharing my screen. I think, yeah, one of the key takeaways is if you're going to be using a lot of historical maps, then you might be better off with perhaps a desktop application, because they can handle raster data much better than any of the web mapping tools, including Carto. We're going to talk very, very briefly about Carto, which has lots of different features. And we're going to be specifically talking about one of the Cartos. Carto has different personalities, and this one is the out-of-the-box Carto that's called Carto Builder. That's the one that we're going to be looking at today. Move on. Carto is an interesting web mapping tool in the sense that you can completely interact with it with your mouse and using your hands basically, but it also has a way to kind of get deeper into the cascading, the styling aspects of your maps if you're so inclined, without having to move into a totally different interface. When we look at it, you'll have a better sense of it. But it has a Carto CSS function. Underneath, the reason why it works very well with relational data sets, different layers of, say, CSV files or Excel files, and relate them to one another and filter data underneath Carto that enables all of that. To do it is the SQL query language that it works with. So if a lot of the terms that might be unfamiliar at first actually come from the SQL language, and there are lots of resources to learn that. So if you're going to get into Carto, it definitely would be helpful to learn a bit of that terminology. For folks who are going to be doing more than embedding and sharing their maps, it has a feature called Carto.js JavaScript. It gives a lot more functionality for folks who are interested in using the map on their websites or sites or portals, so to speak. So there's that extension as well that might be helpful. And for folks who are completely happy using a programming language and such as Python and would like to interact with Carto in that way, they have built what is called Carto Frames. I think it's a riff-off from data frames, and it enables users who are kind of that way inclined to work with their data and maps that way. We have, if you have any kind of questions about GIS help in general, but Carto help, the folks who interact with our MIT's Carto account are at that address that you're seeing on your screen, gishelp@mit.edu. For example, if you need any additional layers, and we're going to get to that in a minute, they're the folks who you need to contact. Hang on. Okay. So I'm going to, we said we would do this hands-on, but we have 15 minutes. So I'm going to try my best to give you a good sense of what Carto does, so that you have an understanding of whether it's a good fit for you or not. And if you obviously have any questions, we can deal with that afterwards. So here is I'm going to actually start with the data set itself, like we are used to, because you feed into Carto your data set, often your CSV file, or there's lots of different Excel, it works with Excel and other kind of file formats too. But let's look at this example. It comes out of Cambridge City data, and I've downloaded it a long time ago. So it covers Cambridge crash data between 2010, I think, and 2016. And if we look at the columns, and the columns in Carto speak are called widgets, and we'll get to that in a second. It has a date time when the crash happened. And I won't go through all of them, but object one is the object that does the crash, does the hitting. Object 2 is the object that is hit. And then it has cross street information where that accident had happened. And obviously we must have, in order to geocode our data set and make sure that it appears on a map, our location, obviously, our latitude and longitude of that location as well. So this is going to be working in the background of when we look at this map. When we look at this map on Carto. So here it says layers, and I'm using 4 of my upper limit, which MIT account, we have 8, we can stack up 8 layers on top of each other. 8 different data sets, in other words, can be stacked up on each other. And here, so if we go, sorry, this is my workflow on the left-hand side. And if I kind of explain to you what kind of maps are in here, what kind of data sets are in here. So the first one, under the bottom layer, the first layer is a polygon layer. I'll just go walk through this, and the layer above that is income. Is about that sort of, again, from Cambridge City Data, pulled out some income data about neighborhoods. There's the crime report that we just looked at, and on the very top there's crash data information. What we're looking at, and I also talked about, widgets. Widgets are columns, but columns can come from different data sets depending on what we're interested in. So each data set, each layer has its own data, and those are the columns in our Excel sheet or CSV file. And I can click on those and they will appear on the right-hand side. Like I went into my crime data set and clicked on the crime data, and it will appear on the right-hand side as a widget. So I can filter all this data that's layers upon layers and look at it from a specific perspective. And the date time information that you're seeing underneath is coming from that crash data that we just looked at. And we can filter the data depending on where we want to focus on. When we can filter multiple sets of data coming from all layers that we stack up on each other, and hone in on a specific thing that we're interested in analyzing. So it's super helpful and useful in that sense. And it works beautifully with the data sets that we have shown you, that's kind of clearly delineated, and especially with numerical data, because it has the MySQL database running this whole game. What I want to show now is another data set, again, Cambridge. Now this is much more simple. It has 2 layers. One layer is a polygon layer. Well, let me refresh that because it's not showing some of the things. And this is what happens with web mapping. That's the polygon layer. And I wonder, when I enlarge the screen, you're not going, it kind of, other features get lost. So I'm hoping that you can use the view options on top of your Zoom screen to kind of zoom in if you're not seeing okay. But I want to show you, so when you click on a layer, a data set, we're right now seeing the map view, and this is right where we're at. So it says the map view is clicked. We can toggle back and forth. This is another feature that I like about Carto. We can go back to the data set and take a look at what's going on over there. This is a very simple 13 neighborhoods. And it does have the, it's basically a geometry, a polygon geometry that is underlying my my data set that consists of 2 layers. And the income data is also, I can do the same thing, toggle back and forth and look at, it has the neighborhood name, it has the area code, it has median household income and median family income and other kinds of information in there. Carto oftentimes, when we'll have longitude and latitude information when we create the data set as it was created, it was in different columns, but it will put them together in the geometry field, and that's how it usually reads that, and will tell you whether it's point data or not. It also tells us whether it's point data or not. If we come over here, so do you see the 3 dots? That's a symbology that Carto uses to explain that it's point data, and the sort of the square is if it's a polygon layer that Carto, that we understand from the symbology. We can hide layers when we don't want to see certain things. We can kind of hide them, and we can sort of hone in. If all I want to see is the income neighborhood, then we can kind of hide that layer and highlight that layer. But imagine the richness of this experience if you have data sets that you need that come from perhaps different periods, whatever the stacking you want to kind of establish there, that can go up to 8 and even more if you need to do that. And you can kind of focus on certain aspects of your data and get a rich geographic information back that way. Any questions? We have 10 minutes. I gotta rush. Want to show you how we style certain things. So I'm in my income neighborhood, my top layer. Here's my data. As I said, those are my columns, the columns in my Excel or CSV file. These are the analyses that Carto has built out of the box in order to do some statistical analyses. And I'm going to put it in the chat that what I would recommend is this link is a link to, I think, all of the Builder features, including analysis. It should have an analyses tab. And in that tab, you're going to see 14, 15 different kinds of analyses with tutorials and sample data provided. I would recommend, if you want to get a really good sense about what Carto does, to pick out some analyses and play with them with either the data set that we have provided, data sets that we have provided for you today, or the ones that they provide, so you understand what it does and what its capabilities are with this Builder out of the box option. The style tab will clearly get us into the style options. And as I said at the beginning, without having to go into a totally different interface, if you can kind of follow my mouse over at the bottom left, you're going to see you can either use your mouse and pick your options here, or you can go into this, flip over and look at the Cartos, get to the CSS options and pick your choices and enter them here that way. So there's that opportunity as well. So right now, all of the neighborhood names are point values, but you're going to see there are lots of different opportunities there. Some of them are pretty cool, and in this one it's kind of creepy. But you can come in here and the style and sort of fix the style in the way that you'd like it. Here's kind of, we can make it giant dots, all of those things. We can change the color here. We can change the stroke size. We can do blending. If you have, for example, in Cambridge, it's just 13 titles for each neighborhood, obviously, so it's not an issue. But if we're looking at a much richer map of lots of different names, it would probably we would want to use some other things to deal with the styling. So you can say, I want some labels. I want to know what neighborhoods we're looking at. So this is the column we want, the same thing as under the data tab. We're going to choose the neighborhood and will let us choose the font. Let's do that. We can put a halo around it. There are lots and lots of different options. We might want the names to overlap or not. I'm hoping that you can see my screen okay. And this one makes the bottom sort of slider makes it the names transparent. Sometimes you might want that, sometimes you may not want that. Anyways, so there are lots of, like the Russian dolls, you kind of, each feature will have different options sort of come your way, and you will need to kind of make choices that way. Right now we haven't, in terms of pop-up, so if we were hovering over a specific specific neighborhood, it would pop up. There are different pop-up options, and we can add a legend, and we have added that legend here, so we can kind of customize our own or do something else. In terms of the cooler features will come with the analyses tab. But before we get to that, I have 5 minutes. I want to be, because there are historians among us, and I wanted to show you, Madeline mentioned that this is actually a weak point of Carto. We can only add one historical map as a base layer. And the way to do that is to come to this custom base map option. And right now I've added it. The other complexity of it is because it's a web application, not only you can add only one historical map, but that historical map has to live on a web service. That is, it needs to be referenced. You cannot just upload it from your computer. It needs to be georeferenced, and it needs to be living on the web, which kind of really significantly limits the options that you might have. In this one, because it's Cambridge, we got lucky, and I'll show you send you the link to the map that we have actually used. It comes out of New York Public Library's Map Warper. And I'm sending you directly to the Cambridge map that we have used for this. But it kind of looks like this. You can't see anything else. It's not really great in that sense. So if you're going to be using a lot of historical maps, maybe this is not a great option, but maybe it is. I don't want to sort of cut it out that way. What you're looking at looking in your screen right now is 2 layers on top of each other, the neighborhood polygon map and the income map. But I've already run an analysis to give you a sense of what it would look like. Let me delete that analysis and backtrack for a second and show you how I did an analysis. So what we're seeing are the 2 maps, 2 layers. And when I want to add an analysis, I go to the analysis tab. Of course, it helps to sort of have a sense of what analysis we want to make. And that link that I provided early on has more than the analysis, but I think I would really recommend that you come to this page and look at, I think there are 14 or 15 analyses here, and they do have both information and samples that you can use. So I'm going to pick intersect and aggregate because I want to see how the income affects neighborhoods or affected the neighborhoods, and see to kind of lay both of that information on top of each other. So this one tells me, here's my base layer, which is the polygon layer. Which layer do I want? I want the income by neighborhood. And I want to have the sum. So I want to have, in this case, because it's, we're not going to be doing super fancy statistical analysis, but the count counts each row. That's not what I want. I'm just going to go with sum. I don't think in this case, because there are data sets nature, it doesn't matter whether I go with average or maximum or minimum, but I want the median income. Select that. And then, I didn't select that. Median family income. Hang on. Sometimes it doesn't take. I'm hoping that it selected that, so then apply. it's as easy as you're seeing on your screen right now to run an analysis. And then in order to make sure that the analyses will work in this case, we're going to go into styling, and we're going to select by value and select that median income, some median family income, and we would like to have it sort of color coded in this way, and so that the richest neighborhoods are going to be in darker colors, and the poorer neighborhoods in less dark colors. And there's a way to kind of, as I said, as I did at the beginning with the crash data, we can kind of limit, we can select the widget or the data or the column that we want to focus on, and filter our final view depending on what neighborhood or whatever piece of the data that we're interested in looking at. That's in a nutshell. I could have gone on, but I'm going to stop here because it's 5:30. And if anyone has ideas, questions, the floor is open. And I'm hoping that it gave you all an okay sense. Obviously, I mean, with workshops, let's grant it, you're not going to learn everything about a tool. But what we hope today was to give you a sense of what it does and give you the documentation you need so you can kind of poke around a little more. And we're always available to help out with specifics.
And I should say, we will make the recording available. So if people need to leave at 5:30, like, please feel free. We'll make this available afterwards. And they are very happy to be contacted, is my understanding. So please, if you need to go, please go, but we can stick around a few minutes for questions as well.
Hi, Michael.
I'd probably just add, since you all know what a GeoBrowser, what Google Maps looks like, you can already probably see that Carto's allowing you to do analysis and edit the data more. And so if you imagine even more full control, that would be the desktop, which we didn't show you that version, but most people know the Google Maps, and that you've seen a web map Carto.
Kate, would you like to go ahead?
Yeah, thanks so much for the presentation. So Madeline, you just said that there's a desktop version of Carto where you get more control than the web version. Is that right? Did I catch that right?
It's actually, Carto falls into the web app category, and then the desktop ones are called the proprietary one that they give schools free things to hook the students that they request in their jobs. The paid for one is ArcGIS, and then the free open source one is QGIS. So there's two, those are the two main monopolies on those.
I got you. Okay. All right. So that was just a new question. But my question is, as some of us are historians, how would you show change over time? That would just be written into your charts and then you run an analysis just like AJ just did?
That's a great question. You would actually have, just like AJ showed in the table, a time column where you have like a time start, or even you could have multiple columns that could say like month 1, month 2, month 3. And there's, for web mapping, there's actually web apps that let you put in a time slider at the bottom of your web app. And so you help it understand what column refers to the times. And then once you've gotten the connection correctly, you just hit play, and then anyone can manipulate it and move it, and it should make your visualization transform as well. And a similar process you would do for the desktop.
You could do that also with the layers on so different time periods data. So if you load, think of each CSV file as one of them from 1960s, the other next one from the 1970s, you can kind of lay them on top of each other and see time across, change across time that way as well. I think there are multiple ways of doing it. So those are the two that came to our minds right now, but sure.
Great, thank you.
Peter, would you like to go ahead?
Yes, I had the same question about time, but how about zooming in and out on the spatial scale? Can you do that also?
That's another huge benefit of a web app is that you can zoom in wherever you'd like. And when you export the map to a friend or colleague, they can zoom in wherever they would like as well. While the static desktop one, you have more control, but you're pretty much producing like a publishable quality map with the desktop software. And then the web maps, you're much more interactive, but you just have more limited data sets you could add it, but you have more functionality in that.
Mhm. Yeah, I mean, just like Madeline said, that's absolutely right, but it also would matter how much you want to zoom. A lot of archaeologists use satellite data, and I think Carto would not be able to handle any of that. So it really depends. But in terms of if we're just talking about zooming, just like you zoom in Google Maps or something, yeah, Carto can definitely handle that, or any web mapping app will handle those kinds of things.
And so am I correct? If it only handles one raster map, but could you digitize, say, a historical map into a vector file, which would then could be edited on top of, say, the one raster map?
100%. That's a great way to go about it. Because often the map, you really just want maybe those old villages, or my mom does caving a lot. She used old USGS maps used to tell you where caves were until everyone would go there and get injured. So caving groups like the really old maps because they digitize the locations, and then they have all these GPS points where they safely and do conservation in the caves. But also the ArcGIS Online, which again is paid for but free when you're at the school, is very powerful, and they get around the imagery issue, the raster issue, by they have a server that has the images, so you don't have them downloaded to your own machine, which in some cases, if you want to do more analysis, is not helpful. But if you just want to visualize, there's tricks that you can just have the data kind of being served to you, but you don't actually get to hold it or manipulate it. But if you just need it to look at it, then there's ways to have more rasters at once.
Mhm.
In QGIS too, right, Madeline? That might be, if you're working with a lot of raster data on top of each other, then QGIS is another good option.
And a good question in the chat, is it possible to have collaboration? And she's talking mainly about the desktop ones. So the web maps are better.
Absolutely, yeah.
They can have more collaboration. I think you can just send it. Well, maybe none of them do you work real time at the same time. Not a geo browser, not a web map, not desktop, but you can send them to someone, have them edit it. So no, actually, to answer your question, I guess none of them are very real-time collaborative, but you can certainly send everyone the data and then get back what they tweaked. But good question, never thought about it.
You could have a Carto account for your project and have the same password, and all the students could, but it could be tricky to work on it at the same time, but they could work on the same map or same interface, and everything can be located in one place, or they could share, as Madeline was saying. It's super easy to share back and forth maps on Carto for sure.